Today's lesson is about intersection of vector lines. Before we get started, let's go over angle between two vector lines. For an acute angle cosine theta greater than 0, so we can use this formula. We can put the absolute value of dot product of two vectors b1 and b2, so that we make sure cosine theta greater than 0. For parallel lines, we know that vector d1 equals k times vector d2. Then we could say d1 and d2, these two lines are parallel to each other. For perpendicular lines, d1 and d2, if the dot product of d1 and d2 equals to 0, which means d1 is perpendicular to d2. Let's go to guided practice 4. The line L1 passes through this point and parallel to this vector. The line 2 has direction 5, 4 and cut the y-axis at 0, 8. Find the acute angle between the lines. As we know, the angle of two lines will be this formula. B stands for the direction vector. Therefore, we only need to use the direction vector for these two lines so we can figure out this acute angle. For A, this will be the direction vector. For L2, this is a given. We can write down 5, 4. Unit vector form. This will be B2. Therefore, we will figure out cosine theta equals absolute value B1 times B2. Then magnitude of B1 times magnitude of B2. For B1 times B2, we will get multiplication of corresponding component, then we add together. 5 times 4 plus 4 times negative 3. And then for magnitude of B1, that's 4 square plus negative 3 square times square root. For B2, 5 square plus 4 square. So we will get 8 over. This is 5 times square root of 25 is 5. Square root of 25 plus 16 is 41. Then we need to put into calculator. Theta equals inverse cosine of 8 over 5 square root of 41 equals. We will get theta equals 75.53 degrees. Remember, when you do the inverse cosine, you have to put the mode into degree, not radian. Now let's go to B. Find the angle between the lines L1 and L2. For the formula, remember B1, B2 are direction vector. So for L1, this is a direction vector. we call B1. This will be direction vector B2. Now we plug into this formula, cosine theta equals B1, B2, that's 3 times 3 plus negative 16 times 8 plus 7 times negative 5. Then do absolute value. Then we do magnitude of B1, that is a 3 square plus negative 16 square plus 7 square times square root 3 square plus 8 square plus negative 5 square. So we put into calculator, you will get the top. You don't have to simplify this square root. Anyway, we need to put into calculator. Theta equals inverse cosine of 154 over square root of 314 times the square root of 98 equals 28.61 degree will be this theta. Now let's go to C. Find the measure of angle between the lines. We are given these two linear functions. We need to figure out direction vector. Direction vector is related to the slope. If I have a B, that's a direction vector is x, y, which means the slope equals y over x. Backwards still right. Therefore, I will get y equals. Isolate the y equals on one side. We got the x minus 3. So I write down y equals x minus 3. For second one, we got to do 2y equals negative 3x plus 11. We minus 3x both sides, then divided by 2, everything. So y equals negative 3x over 2 plus 11 over 2. Therefore, for m1 equals 1 over 1, we need the fraction form. For m2 equals negative 3 over 2. Therefore, for b1 equals 1, 1. You could see this is y over x. So we need a vector form for b2 that equals 2, negative 3. Remember, for vector form, it's always xy. Therefore, for cosine theta equals b1 times b2, 1 times 2 plus 1 times negative 3. Don't forget absolute value. Then square root 1 square plus 1 square times square root 2 square plus negative 3 square. You will get numerator is 1, denominator square root of 2 times square root of 13. Therefore, for theta equals inverse cosine of 1 over square root of 26. We put into calculator, we will get 78.69 degree. Let's go to guided practice 5. Line L1 vector equation is this. L2 is perpendicular to L1 and has a direction vector this. Find the value of x. We still need direction vector so that B1 times B2 equals to 0. We know this is a B1 and this is a B2. So B1 times B2 equals 3 times 0 plus negative 16 times negative 3 plus 7 times x. We set up equal to 0 so that we can figure out this x. 48 plus 7x equal to 0. Linear pattern equation. Therefore, we get 7x equals negative 48 divided by 7. X equals negative 48 over 7. Therefore, when you deal with the angle of two lines, direction vector are very critical. You have to know how to figure out direction vectors for each line. Now let's go back to intersection of vector lines. If two vector lines intersect, you can find the point of intersection by setting the equation equal to each other. Solve for one of the independent variable and then plug back into the equation to get the coordinates of the point. Now let's go to guided practice 6. Use vector methods to find the coordinates of P, Q, and R. We got the vector equation of line QP, QR, and PR. We use a vector equation for QP and QR to figure out the coordinate for Q. When you check this vector equation, you could say they both pass through 3, -1 point. Therefore, for Q will be 3, -1. That's the coordinates for Q. Now I use the vector equation for QR and PR to figure out this R. First of all, we will set up these two equation equal to each other. This is gone. So we set up 3, -1 plus s times 17, -9 equals 0, 18 plus t times 5, -7. For the first row, we will get the 3 plus 17s equals 0 plus 5t. For second row, we get -1 minus 9s equals 18 minus 7t. We label this is the first one, second one. Now change both equation into standard form. You will get 5t minus 17s equals to 3. And 7t minus 9s equals to 19. Let's label 3 and 4. Multiply by 7, and this is multiplied by 5. So that you will get 35t minus 119 s equals 21. And 35t minus 45s equals 95. We need an opposite variable, therefore I change the sign, negative, positive, negative. Then we add together. So that get rid of this t, you will get negative 74s equals negative 74 s equals 1. For this kind of problem, you don't have to figure out t. As long as you figure out one variable, that's enough. Now we need to plug into this equation to figure out the coordinate for r. So we have xy equals 3 negative 1 plus 1 times 17 negative 9. You will get 3 plus 17 negative 1 minus 9, which means 20 negative 10. Therefore, for r, the coordinates will be 20 negative 10. Now we can use QP and PR to figure out the P. We will set up these two equations equal to each other. Therefore, we have 3 negative 1 plus R 14 10 equals 0 18 plus T 5 negative 7. So we change into system equation. Look at the first row. We have 3 plus 14R equals 0 plus 5T. The second row, we will get negative 1 plus 10R equals 18 minus 7T. We need to solve these two equations, labeled as 1 and 2. Change into standard form first. We will get 5t minus 14r equals 3. And 7t plus 10r equals 19. Multiply by 7, and this is a 5. You will get 35t minus 98 r equals 21. 35t plus 50r equals 95. We need an opposite variable, so we change the sign. This is negative, this is negative. Then we add together. This is gone. You will get 148 r equals negative 74. So we divide it by negative 148 both sides. R equals 1 over 2. Now we need to plug into this vector equation to figure out this xy. So for xy equals 3 negative 1 plus 1 half 14 10. You will get 3 plus 1 half times 14. Negative 1 plus 1 half 10. You will get 3 plus 7, that's 10. Negative 1 plus 5, that's 4. This will be the coordinate for P. 10, 4.